Mm.
Then share the screen.
Maybe they thought we've closed for the day. Okay. So there's a question I want to ask.
Go ahead.
If you, like, for example, now, this online 22, if you say T is equal to names, automatically the position comes out.
Yes.
No, that T is equal to names. Yes.
It no longer follows positions.
Yes. So that means if you put your T now, it overrides the code position that's supposed to come with it.
Okay, we can do that. We can try it, but now there's nothing like T in our function, right? Then you then just came and say T equal to Jen. Let's see what save it. Then you run. You see,
Yeah,
it got
it's
an unexpected keyword argument.
T.
It doesn't know what T is.
Yes.
So when you want to do away with position, you have to use the proper T in the function. So it doesn't know T, but the function knows P and A. Yeah. So the learning from this is for keyword argument, you have to call the actual argument of the function, say like B, say A. But if you don't do this and just send your names directly, you just know that, oh, it's going to take two names. But in this instance, you need to know the name to put first and the name to put second. Okay. Right?
Yeah.
So in some functions, you know what should be put first and what should put second. You don't misplace it. That way you're dealing with position. Okay, the first thing you put when you're calling this function is this. Then the second thing you put is that. For example, when you are doing that function we use today, from random, you say rand int, right? When we now take rand int, the first thing you must put is one of like this starting side of it, and you put the 5. Say between 1 and 5. Something like that. You not switch it. You know, okay, start at 1, end at 5. Like, okay, let's say, I think a better example would be the range from this point to that point. So you know that the first place should be the starting, the next place should be the ending. Range takes start, stop. Let me write it to range. Range has a start here. And then stop. And then step. So you would not come and say, you know, 50. You have to positionally put the first number as the start, the second number as the stop, then the third number as step. But with this now, with keyword argument, you can actually put the step first. Okay. Let me just put my mouse over it and see how it is. So what it is called here is actually underscore start. You can see how it is, right? So I can then use this keyword and pass in step first before we talk about stop and start. Okay, so that's about that now. Now again, what if we don't know the amount of keyword arguments to be passed in our function? Just the same way we didn't know the amount of arguments, we use star. You can then have a function that takes a number of keywords argument. And that one, you would have a double star. So I can say star star. Let's call the argument. Let's say star star keyword argument. Okay. When you pass this into a function, just the same way we passed this one, okay, you can take any number arguments and it will pass into the function as a tuple. You can see it's a tuple. Now, if I have star star before the argument, double star instead of one star, it becomes keyword argument. And this case, it becomes a word dictionary. It's passed in as a dictionary. So let's now do what we did before. So we'll see it again. Comment this out. So if I have this, I can then print. I can print the keyword argument and see how they come out. Now, if I call this function at this point, you can't call it with positions like this because this only accepts keyword argument. So I have to have, say, I can say A is equal to James, B is equal to Peter. Okay. So when I run it, you can then see that it's printing now. In this case now, A and B are not like the keyword for the function itself. Okay. We are just dealing with any amount of keyword. It doesn't have to be like, oh, the function knows what A is or the function knows what B. In this case, you can even say T. I can say T is equal to James. There's nothing like T in the function, but the function only expects that the arguments I'm going to pass into it will have a key and then what the key is, and key and is equal to Peter, right? But I can pass in any amount, can even add another one, say age is equal to 10, height is equal to 1.75 meter, make it a string. Okay, so I can pass any amount. Now, when it comes into the function, that's what I'm trying to run, and so you see it now. It comes in as a dictionary. Can you see this? If I copy this now, which is what I'm saying now, when you now have this star star keyword argument, it will enter into your function. If you print it, what will it be? It will be a dictionary. So which means each key word will become key value, key value, key value, key value in a dictionary. So you have a dictionary of T. Let me put it beside this one. Oh, and so it's inside our function. Our function is called names. Instead of our function now, this T equal to James will now become like a dictionary where the key is T and the value is James. Another key that entered is B and the value is Peter. Another key that was passed is age and the value is 10. Another key that was passed is height and the value is this. So this way now, if you want to work with this, you know that you're expecting a dictionary and then you process it as such. The same way when we are trying to do sum and we have any number of arguments, we had to rewrite our sum function. Instead of us to just do A plus B, we knew that the sum is the arguments are going to come inside as a tuple. So we had to say something like for number in A, then we perform the operation because it can be any amount of number. That's how this works. It can be any amount of key value pair, but just know that when it enters into the function, it is going to be a dictionary.
I want to ask a question, please. What is this quag?
Keyword argument.
Okay, keyword argument. Okay.
But
Okay,
you
that's
must
just
not
the
you must not even call it quag. Or you can even change the name now and say B, right? But many places you will see it being called quag. Anytime they do star star, they will say quag. it's not like you must always call it quark. You can call it B, anything, but it's just for you to know that it's keyword argument. That's what that quark stands for. So if you run it,
Because
it
I
still
thought it was a
works.
foreign language. I thought it was a foreign language.
No, it's not. Just keyword argument. So it doesn't have to be that particular word, right? It can be any variable name. But the idea is when you have double star before the argument, it is going to expect that the user will pass in keyword arguments. And when you have it like this, it can be any number. The same way you have this for any number of arguments. Okay, so these two. Then they can also be combined, where somebody can say, def my phone, and have something like this. Sometimes you see this in some functions. Somebody might do it like this. Why is it like this? It's trying to say that, okay, fine, this function takes any amount of argument, and at the same time, this same function takes any amount of keyword argument. So when you're calling my function, you can pass any amount of argument or any amount of keyword argument at the same time, and it will handle it. Does that make sense? This is
Yeah.
kind of combining this one and this. It's like a combination. This one takes any amount of argument. This one takes any amount of keyword argument. This one takes any amount of arguments and keyword argument, which means in the end of the day, when you run this function, there are two things that will enter into the function. And one of them is going to be a tuple, and the second one will be a dictionary. Now, you that is writing this function, when you want to access what the user is passing into them, you know that you're going to access one as a tuple and as a dictionary. Then you would write your function to collect the data or from the tuple and do what you want to do it, or from the dictionary and do what you want to do with it.
So
Okay.
with this function, one can create a dictionary using function. Is it possible?
No, not like creating, don't look at it as we want to create a dictionary. Let's use function to create a dictionary. Look at it like you're passing argument into the function. But when this argument is passed into the function, how will it be? In this case now, if you look up here, when I pass all of this into the function, inside the function, it saw it as a dictionary. That's what I'm trying to say. Even though you put it like this, inside the function, it is seeing it as a dictionary.
It's a dictionary, okay.
So if I'm writing the function and I expect it to collect any number of keyword arguments, then when I'm processing it, when I say processing, that's in this case now, when I say add num, when I'm trying to add the numbers, I have to know that the numbers are stored in a tuple. So I have to access them from tuple to add them. Okay. Now, in this case, you know that the arguments are stored in a dictionary. If I want to access them, if I want to process them, I will then work as if I'm dealing with data in a dictionary. Okay. But at this point, I'll say, okay, don't trouble much about this. It's not something that you see every time. I'm just throwing it here because we are dealing with function. Okay. And we'll stop here for the function instead of going further, because it's getting, I don't want it to get to a point where you might now like feel confused. At this point, it now calls on us to go back to the exercise book and then do those exercises. They are not going to get, they may not even use all these keyword arguments and argument there, or they may just use it few times. But
Okay.
when you now begin to write your own function, you appreciate some of these things better. If not, it just sounds like, okay, good to know, good to know. Oh, I understand what he's saying. Okay, okay. But these things are tools for you to use in actual development, in actual writing of code, in actual programming. Okay, because by what we have learned in the book up to this function, you can actually write a full script Python. Even almost you should be able to write like an application. Okay, but there are certain things we've not touched, like creating a module and a package. Some little bit of knowledge here and there. But if you've been doing the exercises, you already know Python to a great extent. There are many things you can solve if you were solving the exercises, or not just attending the class or listening to the lectures. That's what we say. By the time we get to chapter 14, you've covered the basics of Python. You can do
As a
most of the
object
things.
object
Object
oriented.
oriented. Yes. So in programming, there are two major paradigms that are used. See, someone can either be doing functional programming, or object oriented programming. See, so this functional programming now, the foundation is the functions. So I can write different functions, and then use them to achieve something. And write an application, function. How I can structure my application in an object-oriented fashion, which is the chapter 14, when we now talk about object-oriented programming. Python itself, most of the things in Python, everything in Python is object-oriented, is objects. Everything are objects. We've not been speaking about object, but when we get to that chapter, we'll then start speaking about object. For example, when you have a string, is an object of class string. So in object-oriented, we're now talking about classes and objects. Classes and objects. When we get to that, you will then see that everything in Python is actually objects and classes, objects and classes, objects and classes. But at that time now, your knowledge of Python now is now becoming advanced. But now where we are is functional, where we're talking about functions. How do you create functions? And you can begin to see the beauty of programming, in the sense that almost all those solutions we solved from chapter 1, chapter 2, chapter 3, you can begin to create them as a function. In the last class, I said something. If you are solving those questions the way we ask you to solve them, you find out that when you solve number 1, you comment it out, you do number 2, you comment it out, and so on. You can actually, number 1 can be a function. Like we previously, we are given maybe in chapter 1, we are given an exercise to print something like this. And then have it like this. Do you remember?
Yes, so
Yeah, we printed it in chapter 1, right? That thing you did, just the solution of this, you can put it into a function, right? There were 19 stars, for example. Someone can then come and say, okay, let me do a function def box, def print box. And I'll say, let it have an argument of size, which is how maybe how long the width. Or let me just say width. Someone can even come and say width, and then height. And for I in width. No, height. Height talks about this, so height. For I in height. For I in range. Range height. Because height is a number. For I in range height. I can then say also for J in. No. Okay, width. Okay. For I in range height, I can print x times width. X times width. Okay. So this is print box. Then let me now call the function, because we always call function. So let's call the function. We say print box. And the argument to pass, there are two of them. You must put two arguments, if not, it's going to complain. But we can make one a default argument and say the height is 4. Default is 4. So even if you don't supply the height, so I can say print box 19. What this does is I'm saying, hold on. What this is doing is that I'm saying that the width should be 19. Let me save it around and get it. So you can see now, 19 is the width, how fat it is. Okay. Why the height by default is 4. So it's 4 lines, 1, 2, 3, 4. Now, with this my function, someone can then say, okay, I want it to be, let's say 10 instead of 19. And I want it to be 10 by 10. Height should be 10, width should be 10. Save it and run. So you then see how it came out. Now, instead of me to be like, this is the first one that is 19, this is the second one that is 10. Instead of me to every time be writing the codes to produce that print, I put everything in a function. I can call this function different times with different arguments. Maybe I put 10 by 10. I'll come again, print 5 by 5, print 5 by 3, print this. Any amount, I can just be printing them. Because now I've wrapped that same solution we had in chapter 1. I've put it in a function. Even if you were to put it, you may not put it the way I put it, like this, right? I only put, the way I put it now is just the way I thought. It doesn't mean you must do it like this. Someone else can still do this same function in his own way. He could say, you can just hard code it like this, times 19, and print it 4 times. If I remove the for loop, don't need for loop in this case. So you don't even need argument. Someone can still write the same function. Maybe you say, oh, my own, I put width and height. It might look a little bit complex. What we actually solved before was just printing 4 lines, 1, 2, 3, 4 of star times 19. Somebody can just put it as, this is a function too. If you call print box, if you call this print box one time, it doesn't need argument now. Just call the print box. That thing happens. I'll just put this print in between for space. This one is for a space. And then if you save this file, run it, you find out that it printed twice. You see them? But the idea is that it's now a function. You can call it as much as you want. In this case now, the function is fixed. You must always print 19.4, 19.4. But the other way I wrote it now, somebody can vary the width and height because I allow the user to supply it as argument. What I'm trying to say now, in essence, most of those solutions we are doing single would be put into function. Now, the mindset to have when you're programming, anything you're going to be repeating, any set of lines of code that you're going to do it more than once, you do it later in your code, you do it again. You just need to wrap it into a function and rather call the function. Then if variables are changing, let those variables become arguments that are passed into the function when you're calling that function. Like the add number, which we had, let me see here, A and B. You know, if you always want to add two numbers, A and B, it can be any number. You can call it any number of times in your coding. So most of these things I'm saying will just still sound like story. But if you go and do the exercises, you will get it. Especially this function. Try and go and solve this function and it will make you write different functions. Immediately you will get used to the return keyword. You get used to the functional structure. If you don't, you will not get used to it. For me now, you can see that even as we are doing this class, I might be able to just come up with a function and you will say, oh, how am I able to do all these things like that? It's just because I've been doing. There's no magic there. It's just like I've just been doing, I've been writing, right? So I'm used to writing a function. Okay, I just write. I've played around and played around with it. You now need to start your own playing around and playing around, which is by doing and doing. You get used to it. Okay? So the difference between you and me is just that I came before you. So I've done more than you have done. You're just trying to start now. But if you do those exercises, you might even know better than me. There is no law that even said because I came before you, then I must always know more than you. No. If you go now and do your own, you can even bring it in your own way that might be better than my way. That's why programming and software engineering is nice. Everybody it's a tool we use to approach problems of life, real life problems, provide solutions. That is it. It's a mindset, it's a tool that will help you to solve problems. So I don't know if anybody have any question. Okay, in the absence of
No
questions.
question for me. Just as you said, it's just for us to go and look at these exercises.